Go.
All right, so you will have the lab document that's posted in the assignment, so you will have to read along to this. I'm not going to read all the questions for you, so you'll just have to figure that one out. So what we have here is a handheld generator and a light bulb, and you can see that it is attached to the light bulb. So we are going to turn the handheld generator, and you see that it lights up. All right. It says under which two conditions will the light not light. One is if you're not turning the generator. Another one is, keep going now, is if you pull one of the wires off, or you can say if you unplug the light bulb, that's when you will not have a light going. What happens when you speed up or slow down? So this is going very slow, and then this is going very fast. All right, what happens when we change the direction of the generator? So this is going counterclockwise, and then this is going clockwise. So you really can't see any difference there. And then number 4, what evidence do you have that electricity is flowing? You will have to answer that on your own. Now we are going to trade our light bulb for some steel wool. So here is the steel wool. We are going to have the generator turning, and this is our evidence that electricity is actually flowing through the steel wool. Nice and pretty, right? For a blinky bulb, and as you can tell, when it's sometimes on, sometimes off. Now, we know that it is more difficult to push the electricity through when everything is connected. So the feel of the generator is actually, you'll have more resistance with it on than with it off. All right, it says trade our blinky light bulb for a battery. So here's our battery. I'm going to connect the red to the center, thank you, and the black to the other end, and you can see how it is turning. All right, then I'm going to reverse this. I'm going to use 2 hands to do this. So I'm going to put the black in the center and the red on the outside, and you get to see how the generator turns. Okay, so this is our next one. We are doing a series circuit. This is with 1 light bulb going at a pretty constant speed. This is with 2 light bulbs. You can tell they're not as bright. And it's now more difficult to turn the handheld generator because that's to push energy through instead of just 1. And here it is with 3 light bulbs. You can tell it's very dim, more dim than it was. It's even more difficult to turn the handheld generator. All right, so the next question is what happens if I have a bulb burn out? So I'm going to supplement this by taking out one of the light bulbs. So when I take out the light bulb, everything goes out. Okay, this is our first setup with the parallel circuits. You can see that I have 2 wires connected to the light bulb. All right, here is 2 light bulbs wired in parallel. You will see that I have 2 wires in and then 2 wires out for each light bulb here, except I don't have one for that one. But you can tell that the lights have not gotten more dim, but now because I'm still having to push electricity through 2 light bulbs, we are now we have a higher resistance. All right, here it is with 3. You can tell that the light bulbs are not nearly as dim as what you had before, so it's about the same with 3 versus 1. And you see I have 2 wires going in, 2 wires going out, 2 wires going in and out, and all that. Now, the next question is what happens if one of these lights goes out? So let's have one of the lights go out, okay? The other 2 are still on.